For this level, we are looking at process design. So, why would you ever need to design a process? Well, you would need to design the process if you have a new product that you are offering. You need to decide how you're going to make it. Maybe you've had a change in your equipment, and so because you have different machinery, the process now for making your good or providing your service is different. So you need to redesign the process. Maybe there's a change in the methodology. Maybe quality standards have changed. Maybe there's better techniques out now that cause you to redesign the way that you do things within your company. There might be other reasons you need to redesign your existing product. And these could be because you're getting complaints from your customers. Perhaps there are quality issues. Perhaps customers are not satisfied because how the product turns out doesn't match how it's being sold or what they think they're getting. And so we need to redesign the process so that what they're getting is what they want. So for example, let's say we make an iPhone or another type of smartphone. Well, if customers aren't happy because I drop the phone and it breaks, then we need to redesign how we make the phone. That could be a quality issue. If customers now expect that the phone be waterproof, then we may have to redesign how we make it, what we use to make it with, and so that process for assembly may change. So if customers aren't happy, if there's a quality issue, maybe it's just taking too long to make it. So we need to be able to turn around this product much quicker, and so we found a new way, the faster way to make our product. Then we need to redesign the process. Maybe our management are spending all of their time putting out fires. Maybe the current methods that we're using to produce our good are creating problems, bottlenecks within our production line. So maybe the way that we're producing it means that we're constantly moving our work in process or partially created inventory back and forth, and that's creating kind of traffic jams within our company. We're having to put out fires in terms of customers not getting the products they want when they want it. Maybe we're having an increase in defective products because of the current process that we're using. Or maybe it's causing issues in terms of overuse of certain materials, shortages of materials, and so management is constantly running around trying to put out these fires, find enough inventory so that we can get what we need to the customers. So there are a number of reasons why you might redesign your existing product if your process isn't working and you need to find a new one. So what we're looking at in this level is that process. How do we design a process for making a good or providing a service? So one thing we're going to do in this level is look at process flow diagrams, and what you see here along the bottom is a process flow diagram to create bread. And so we'll look at how process flow diagrams are laid out. But first, we need to look at the different types of process designs. So let's define process design. And a process design is where you are determining the form and function of how goods and services are produced. So there are 4 general types of process designs. These are primarily for goods, although some of them work with services as well. And so the first one that we're going to look at is called a job shop. This is where you're more project-based. Then we have batch. So we're doing it in groups. And then we have repetitive, also called mass production. And then we have continuous. So we're going to look at each one of these, but the key distinguishers between them is how large of a quantity are you producing, how much variety, so how customized is the product, is it all the same, is it standardized? We can also look at the type of equipment that we're using. Is the equipment very specialized? Is it more generalized equipment that gives us flexibility so that we can change what we're doing? So we're going to look at those. Now let's start first with the job shop. So a job shop is characterized by low quantity production and high variety or highly customized goods. So the goods and services are customizable. We can adapt them to each client. We can make exactly what the customer wants. So when we do this, what we're doing is we are requiring a much higher variable cost because we need highly skilled workers. And we have a much lower fixed cost because the equipment that we're using is more multi or general purpose equipment. So when we think about a job shop, you could think about an emergency room in a hospital, for example. In an emergency room, everyone has a different ailment and everyone needs a different treatment. So there's lots of variety there. Now, in terms of the number of people we can treat in an emergency room, it's very limited. So the quantity is low, and that's to allow for the fact that every single person needs something different. When you think about the equipment that's used in an emergency room, things like scalpels and syringes, they can be used for many different things, all kinds of different procedures or surgeries. So the equipment is more multi-purpose. There's more flexibility in terms of what we can do with our equipment. Now, this creates some challenges when we're using a job shop because, well, think about the emergency room. When in the emergency room, you can't really control when those people are going to arrive who need your care. So it's quite possible that tons of people arrive all at once and they all need something different. And then there's other periods of time where the emergency room is empty. So scheduling jobs to meet due dates and to properly use and make sure you have enough resources can be a challenge. So let's compare this job shop now to the second type, which is a batch process. So a batch process, when we look at it, has a bit more quantity. So we can produce a bit more, but in exchange, we're going to have a bit less customization. So we're going to have variety of goods or services, but not to the level that you saw with the job shop. So we increase the quantity, we decrease the customization. So still a bit of variety, but not as much. What really distinguishes the batch process is that the process is intermittent. So we do things in chunks, in batches. The equipment that we're using is not going to be as flexible or multi-purpose as the job shop. It's going to be a little bit more specialized. So when we think about a batch process, you can think about, for example, a bakery, right? A bakery can make multiple loaves of one bread, and then they switch and they make multiple loaves of a different kind of bread. So they're doing it in batches. And so we're not continually making the same kind of bread. The process is done in chunks. That allows us to increase the quantity and have variety, but not as much as a job shop where you're making each particular item special for the customer. Now, some other examples of a batch process would be movie theaters, right? There's different movies you can watch, but we're loading in 100 people or so, maybe less, 50 people into each theater for each show. Airline, same way. Each plane goes to a different location. We can put 100 people or so on a plane and send them off in different directions. Now, there are a number of challenges created by the batch design. The one is technology management. This has been an issue lately for the airlines, right? Anytime they're scheduling or any of their databases that monitor where planes are landing, leaving, anytime that goes down, the whole system goes down. Because it is scheduled, those batches, you need the planes to leave at a certain time, arrive at a certain time so that you can have the next plane come in and go out. So scheduling becomes an issue, and if your technology is down, that interrupts your ability to schedule those batches. We can also have capacity issues, so think we can't add one more person to the airplane. When the airplane is full, it's quite expensive to add a whole nother airplane if you're only putting one person on it. So really, our capacity is in chunks, and so we can have issues with, well, you can't have one more person fly. Same thing with movie theaters, right? You can have issues where there's just not room for one or two more people. You don't want to have another showing just for those two people. That can be expensive. The other issue we see with movie theaters is because of that scheduling in batches, we see periods of time where, for example, at the food counter where you're getting your popcorn, your drinks is super busy, and then other times where there's nobody there, and that's because of scheduling of each of the movies. So think about each movie as a batch, and at a lot of movie theaters, they're not timed or staggered enough. What happens is a lot of the movies start around the same time, and so you get everybody trying to get their snacks at the same time, and then during the movies, there's nobody at the snack bar. So you can have those scheduling issues with a batch process. All right, let's look at the third one. No, before we do that, here is an example of a batch process. So in this case, they're making beer. And when you make beer, you mix the malt and the water, you boil, you separate the solids and the liquids, you ferment, you age, you filter out, and then you package it up. And so you can see here on the right, this picture here shows you the vessels that they make batches in. All right, so we've looked at job shop, we've looked at a batch process, and now let's look at the third one, which is a repetitive process. A repetitive process is also called mass production. In this case, we have a large quantity and we have standardized output. Now, repetitive processes often use assembly lines, which are production lines. So production line where parts are added sequentially. Okay. So then the question is, what's a production line? Well, a production line is a sequence of machines or workstations that perform some kind of operation. Operations on a product. So when you think about a production line, an assembly line, you think about when they are making cars. Okay, so we're doing the assembly in order. We have a set order to it, the cars move along, and we have our machines or workstations that are performing each step in the process. So we have an assembly line, which is using our sequence of machines to add parts in a particular order. When you think about a car manufacturing, you can also think about it as a repetitive process because large quantities of vehicles can be produced, but you don't have tons of variety when it comes to cars. Most manufacturers have a handful of different models, and you can choose kind of a couple combinations, right? So for example, if you're talking about a Ford F-150, you can get an XLT, you can get a Lariat, You can get a platinum. There is some variety, but it's very limited. You have just a handful of choices. It's mostly standardized output. Some challenges that are created by the process design. Well, the first is capacity balancing. The idea behind capacity balancing is if you have different aspects to producing your good or providing your service, then do they have the same capacity? So if we're looking at let's say we're looking at a cafeteria. Okay, so if we look at our cafeteria and everyone goes through the line to place their order, grabs their food, and sits down. Well, when we look at capacity balancing, if we are going to add another line in our cafeteria so more people can order and get their food, does that match the number of seats that are available to sit and eat at? We need those to accommodate the same number of people. Because the last thing you want is to push more people through your line, but then they have nowhere to sit and eat. So we need to make sure they match. When it comes to repetitive processes, we also have to think about technology management. And so because we're doing things in a sequential order, we need to make sure that information is being passed along the line and that each part of the process knows what to do. So how are we managing information about inventory in terms of what the machines are doing and so on? We have to look at quality and the impact that has. The challenge with a repetitive process is that because it's a sequential process, well, think about a car wash. All right, so you pull your car into the car wash and it's supposed to do a number of steps sequentially, right? It rinses the car off and then suds it up, rinses that off, add some wax, and so on. Well, if one thing is down in terms of your production, let's say let's say the machine that provides the soap is broken. Well, the problem is that we can't wash any cars then because of that sequential process. If the machine works properly, but we run out of soap, then it's a materials or inventory management issue. And again, the whole production process grinds to a halt. So we have to make sure that our technology is working, that the machines are doing what they are supposed to be doing, that we're not creating defects, that we have all the materials that we need. When any of those break down, because this is a sequential process, the whole thing stops. We're also trying to get a large quantity produced, and so we need the output to be very similar across, and so quality management becomes a big issue in these cases. We said a car was an example of a repetitive process. Here is the process for creating a Packer truck. And so you can see here pulling in the frame, so the chassis, then we're mounting wheels, we're mounting engine, we're painting the final product, and you can even see here on the right how they might lay out their facility. So there's some variability in production. Higher quantity, a little bit of variability. In comparison, the next type of design, the continuous one, has no variability at all. Every product is identical. So the last one here, this continuous one, allows for an even larger quantity. And that's because there is no variability at all. So while the previous one had a standardized output, I did have some variation. This one has none at all. The equipment that we use is going to be very specialized. So it's not going to be multi-use equipment. It's going to have one role, do a particular task, and that's it. So there's not flexibility or general use in your equipment. It's very specialized. The workers are going to tend to be low skilled, so our money is going to be into these expensive machines and our variable cost will be lower. So it's the other extreme from the job shop. When we think about a continuous process like this, we're thinking about the production of products like steel, paper, sugar, flour, salt. If you're Nova or Dow and you're making polyethylene, polypropylene, it's a very standardized production. There's no variety in the output. Every little plastic pellet's the same. Every grain of sugar is essentially the same. And so you can see here, here's the process of creating sugar. Large quantities being produced all at once. No variety in the product. Challenges that are created by this, well, it's also going to have capacity balancing issues, technology management issues, quality and material management issues, just like the repetitive process, for the same reasons really. Because if you have part of your process able to handle a certain amount of production and others not, you're going to create bottlenecks. If your technology goes down, if you're creating poor quality, if you don't have enough raw materials because of this mass production through a sequential process, it's going to drastically impact your ability to produce. In fact, it could shut down your production. The additional challenge that we have with continuous production is often it's difficult to start up and stop the production. So for example, if we look at companies like Dow and Nova, they have to schedule their maintenance months and months in advance. It takes weeks to shut down the system because you can't leave plastic in any of the pipelines because it'll harden. And so everything has to be flushed out before you can stop, and then it takes weeks to get started up again. So any unscheduled maintenance or issues with quality or production can be very costly, because not only do you have the issue at hand, but you have the added delays of the time it takes to start and stop production, and that can be quite expensive for a company. So let's compare the different types of processes that we've talked about. So let's create a graph here. So the 4 process designs that we had, we had the job shop, we had batch, we had repetitive, and we had continuous. And we can distinguish between the 4 essentially by looking at the volume that's being produced. So job shop is going to be the lowest quantity, and continuous is going to be the highest. So we'll put an arrow showing the increase in quantity goes from job shop to continuous. We can also look at the level of variety or customization. How able are we to make different versions of a product, especially make it for each customer? Well, the job shop is going to have high levels of customization, and continuous essentially has none. So we'll put the arrow up to the highest version. So you can see there's a trade-off here between the quantity that's being produced and how many different renditions you have of it. We can also look at the issue of the equipment. So in the job shop, we said we had more general purpose equipment. These are tools that can be used for lots of different things. So we could call them very flexible in terms of what they can be used for. Whereas continuous tends to be very specialized equipment. It's specially made for one aspect of production, and it only does that one thing. So the closer you get to job shop, the more general purpose your equipment. The closer you get to continuous, the more specialized the equipment is. Alright, so let's go here. And so that's essentially what this table is showing you here, that trade-off. Now, when we look at companies, they can choose the level of quantity and the level of variety. So In job shops, we talked about emergency rooms, companies that do repair, because they are, whether you're repairing appliances, whether you're your plumbing repair, every job is a little bit different depending on needs. So a lot of services tend to be job shop. Batch, that we talked about the bakery and the theater. And more repetitive, we talked about car wash. We talked about producing cars. So then we have the other extreme, the continuous, and so this would be your manufacturing, where you're producing identical goods. So steel, producing clean water, those types of things. Now notice that in these cases, we don't have any products that are in this category here, right? It's inefficient for companies to be both high variety and high quantity, or low variety and low quantity. Those don't make sense. They're not profitable for companies to be on these other extremes. Low quantity, low variety, high quantity, high variety. And we can look at an example of this, and this would be McDonald's. So last couple of years, McDonald's has been trying to add where you can build your own burger. The idea is to add more variety so you can custom make your hamburger to be exactly what you want. The problem is, at the same time, they're trying to be a high quantity company. That is, they can serve lots of people very quickly. And they've tried this twice now. They tried it the last couple of years. They tried it about 2 decades prior to that. And it never lasts. It's a very short-term plan because they don't align. Because you can't have high quantity and high variety, it's inefficient for the company. It also doesn't make sense for a company to be low variety, low quantity, because then what's the gain? What are you getting out of that? When we look at these different types of processes, so let's go back to our list here. We have job shop, batch, repetitive, and continuous. How you position your company is really going to determine what type of process design you have. Or what kind of process you have will determine your positioning within your company, because they align. When we're looking at a job shop, it's small quantity, high variety. So your position, how the company sees itself, how it's going to sell itself, is that it offers lots of different customized goods. So it has variety as its position. A batch production lends more towards high quality. Okay. So we think about beer brewing, we think about bakeries, right? It's very much about that homemade taste, that high quality taste. So companies that are batch tend to be quality. When you have a repetitive, your position tends to be based on delivery. So the idea here is timeliness in terms of getting it to the customer. And finally, if you are doing continuous production, typically you're competing based on cost. Large production of a standardized output where there's no variability allows you the most economies of scale. So you can spread out those big fixed costs of those machines, spread them out, and the per unit cost goes down. So continuous production leads to a cost-based positioning.